Hello students, welcome to Gangs of Toppers. In this class, we are going to deal with the two topics. First one is about the atmospheric pressure and the second one is about the factors affecting the atmospheric pressure. Now let's understand what is atmospheric pressure. I think you have already studied in the previous class, that is what is the formula of pressure. Pressure is equal to force divided by area. Now here the force will be acting as the weight of the air. Means here the F will be considered as the weight of the air. Okay, the weight of the air that will come as a force, and if this force is acting over a unit area at a given elevation, then that is known as what? That is known as atmospheric pressure, because we are dealing with the atmosphere, means it is talking about the layer of air. So what is the definition of atmospheric pressure? The total weight of air. Now we are talking about the total weight of air over a unit area. This is over a unit area at a given elevation, then that is known as atmospheric pressure. In simple word, we can say that atmospheric pressure, that is the force exerted by the weight of the air. Okay, now what are the factors responsible for the atmospheric pressure? Okay, now if you talk about this column, suppose this is a column, then you can see that the density of air. You can see that the density of air at the bottom or at the low surface of the atmosphere, you can see that there is more contrast, there is more density of air as compared to at the top of the atmosphere. You can say that the intermolecular space between the molecules or between the air is more as compared to at the bottom of the layer. Okay, means you can see that if the number of molecules at the bottom is more, then it is going to have if the number of air particles is more, if the number of air particles that is the bottom is more, then the pressure is going to increase. Why? Because these molecules will act as a weight, okay, over that unit area, over this person, then therefore the pressure increases. Okay, now if we talk about this person, this person is at the top of the mountain, and the intermolecular space between the molecules is not densely, actually the air is expand, so the intermolecular space between the molecules is less, or actually we are talking about this data. The intermolecular space between these molecules is more as compared to the intermolecular space between this at the bottom. So due to the number of particles at the top is less, so what is going to happen? The pressure is going to decrease. So we can see that there is a natural thinning. You can see that at the top of the atmosphere, the layer or the molecules are not densely compact, but as we talk about at the bottom of the layer, the molecules are densely, the molecules there are dense. Okay, so therefore if the molecules are dense, then the air pressure is going to increase. So there is a natural thinning of our atmosphere with altitude. We can see that as you go to the top of the atmosphere, then you can say there is a natural thinning of our atmosphere. Why? Because the intermolecular space between the molecules is not dense. Okay, therefore as you go, our natural pressure is going to decrease. Okay, now if we talk about the temperature, now first point is about the air particles and next point is about the temperature. Now talk about that. Now if you increase the temperature, what is going to happen? It means that the intermolecular space between the molecules is going to increase. Now if the intermolecular space between the molecules is going to increase, then what is going to happen? So the weight of the air, that is the weight or the force that is exerted by the air, is going to decrease. Means as the temperature increases, the pressure is going to decrease. Okay, there is an inverse relation between the temperature and the pressure. Now just opposite the concept, means if the intermolecular space is going to increase, means intermolecular space between the molecules is going to decrease, means these airs are dense, then what is going to happen? The pressure is going to increase. Okay, so we can say that warm air is therefore less dense than the cold air. Yeah, because you know that warm air, because the density of air is not dense, because intermolecular space between the molecules is more as compared to the cold air. In the cold air, the intermolecular space between the molecules is less and they are dense, therefore the pressure is more. Means if you are going to decrease the temperature, then there is a increase in atmospheric pressure. Okay, now our last topic is about the water vapor. Now suppose that if we are talking about the water vapor, what is the molecular mass of water vapor? It is average molecular mass, or molecular mass is about 18. Now what is the average molecular mass of what? Air. You know that in air we have mostly nitrogen and oxygen. Okay, now nitrogen is about, that is what, it is about 21 percentage, 78 percentage, and oxygen is about 21 percentage. If you talk, if you considering this, only these two air are in the atmosphere, then if you find that what is the molecular mass of, what is the average molecular mass of nitrogen and oxygen, we will get approx 29. Okay, now suppose that we are considering a unit of air, and in that we are adding what, we are adding water vapor in it. So what is going to happen, if we add water in the air, then the space that is occupied by the air is will be decreased. Then what is going to happen, we are adding water vapor, we are adding again water vapor, then the molecular mass or the average molecular mass of that column of air is going to decrease. Why? Because the average molecular mass of water vapor is less as compared to average molecular mass of what is air. So if we increase water vapor, then what is going to happen, that is the weight of the air or the weight of that column is going to decrease, means pressure is going to decrease. Okay, so we can say that if the amount of water vapor is going to increase, okay, the pressure will actually decrease. Why? Because the weight of this water vapor is less as compared to the weight of the air there, because humid air is actually less heavy than the dry air. So we have to remember that humid air is less heavy than the dry air. Okay, thank you.